Good afternoon, my YouTube viewers. It is Crystal here, and I wanted to make a video on the latest Kaggle competition. And so basically, what I used was a Catboost classifier on this Kaggle competition to make predictions. The problem statement for this Kaggle competition is predict whether a Formula One driver will pit on the next lap. So that is the problem statement that we have to figure out. We have to answer. And so I use Catboost Classifier on this problem. And the reason why I use Catboost Classifier is because some of the features were object. And if a feature is object, then you can actually use another classifier, such as random forest classifier, and then just use sklearn's ordinal encoder. And what it would do is it would encode all of the ordinal features. So that's one way you can do it. If you don't want to use Catboost Classifier, you can use one of the classifiers in the sklearn library and then just ordinal encode your object columns. But I decided not to do that. I decided to try out Catboost because I've had really good results with Catboost. And I only did this competition question once. And if I had the time, which I don't, I could, in theory, do the competition question twice. I could do the competition question once using Catboost Classifier and then get my accuracy. And a second time using one of the tree-based models in sklearn, such as random forest classifier or extra trees classifier, just to name two. And so basically, I don't have the time to do it a second time, but if you've got the time to do it a second time, you could do it like I've just described it. And then so what would happen is you would see which model gave you the highest accuracy. Was it Catboost Classifier or one of sklearn's tree-based models, or a linear regression model, or SVM model, or any other model that you wanted to try out? But since I'm limited with time, I'm just stuck with Catboost Classifier, and I'm just giving you some ideas for other classifiers that you may want to try out if you've got the time. And so the first thing we're going to do after we define our problem statement is we want to use Kaggle's Jupyter Notebook. And I have saved my Jupyter Notebook in my account for Kaggle. And then so we're going to import our libraries. So we're going to import NumPy as NP, which helps you to carry out numerical computations. We're going to import Pandas as PD, which is helps you to manipulate your data, which is a data processing. We're going to import OS, which lets you go into the operating system. We're going to import Catboost and Catboost. We're from Catboost. We're going to import Catboost Classifier, which is our model, and Catboost Classifier is designed to work on features that are of a type object in Python. We're going to import sklearn, which provides our machine learning functionality. So we're going to import train test split, which is going to split your dependent and independent variables into training and validation sets. And we're going to import ROC AUC score because that is the metric that we're going to use to calculate the accuracy of the model. We're going to import matplotlib.pyplot as a PLT, so that is a visualization library. And we're also going to import Seaborn as SNS, which is another visualization library. So the first thing we want to do is after we import our libraries, then what we're going to do is we're going to retrieve the files, and we're going to use the OS library to do this. And when we retrieve the files, we find out that we have 3 CSV files, being a train, test, and sample submission. So those are the 3 files that are used for this competition. So what we want to do is I want to set it up so I can view all of the columns in the data frame. And so if you don't set it up to view all of the columns in the data frame, then you won't view all the columns in the data frame. So you type pd.setOptions brackets display.maxColumns, none. And that is the code that you need to type in so you can view all columns in the data frame. And then now what we're going to do is we're going to convert our CSV files to data frames using pandas. So train equals pd.read.csv and then the address, Kaggle input competitions, playground series S6E5 train.csv. And then you type in the same for test and type in the same for submission. So now we're going to see the train. We're going to see train, and we're going to look at the first 5. So you type train.head brackets 5. So that allows you to view the first 5 rows of the data frame. So you can see right here, you've got the first 5 rows of the data frame. It goes all the way down, and the target is pit next clamp, and you can see that this is a binary classifier, but we're not going to be predicting on a binary. We're not going to make binary predictions. What we're going to predict on is the probability that a certain driver is going to pit the next lap. So although the pit next lap is binary, when we make our predictions, it's going to be a probability, and the probability is going to be a percentage from 0 to 99 or 100. And then we check tail, so the last 5. So basically you can check the first 5 and the last 5. And then so you can see that you've got 439, 139 rows. So that's why it's a good idea to also print off the last 5. So you see the first 5 and the last 5. So we're checking for null values. We do not have any null values in this exercise. So you've got 0 null values. And then we check train.info, lets you know what kind of features you're dealing with. It's going to be an integer, an object, and a float. So you've got 3 types of integers in this data frame. So now we're checking test. We see the first 5 rows of the test set, and you can see that we don't have the pit next lap row, and the reason why is because that's what we're going to have to predict on. We look at the last 5 rows of the test set, and so you can see the last 5 rows of the test set is 188, 164. So we check to see if we've got any null values in the test set, and no, we do not have any null values. We check to see what kind of features you have in the test set, so you can see what kind of features you have. Now we're going to look at submission. So we're going to look at the first 5 rows in submission, which gives you an ID and a pit next lap. And then you look at the last 5 rows of submission. And this is the format that Kaggle wants to see when you submit your work. And I know that you're going to be predicting on the probability, and the reason why is because when you look at the information of the competition, the first page of the competition, it gives you a value of percentages. And since it gives you a value of percentages, you know that you're predicting on the probabilities. So now what we want to see is the shape of the train and the test file. So you can see train has 16 columns of data and test has 15 columns of data. And the reason for that is because the test file, it does not have the final column of data because that's what you're going to be predicting on. We're going to drop the ID column. The reason why you're going to drop the ID column is because Pandas automatically indexes every row of data. And since Pandas automatically indexes every row of data, you don't need the ID column. We're going to drop the driver column. And the reason why we're dropping the driver column is because there are different numbers of unique values between the train and the test set. And there's lots of unique values. And so I decided just to go ahead and drop the driver column and hope for the best. So now we're going to check for unique values. So for column in train, print column, comma, train call dot dtype, comma, train call dot in unique, because we're looking at the number of unique values. So the column compound object has 5 unique values. The column race object has 26 unique values. And then you go on down until you get all of the columns. Now what we're going to do is we're going to analyze train. So we're going to analyze all of the columns in the train data frame. And we're going to do that by creating a for loop. And in this for loop, so the first thing we're going to do is we're going to create a variable called calls, which is an empty list. And then for call in train.columns. So that's going to be, you're going to calls.append call. So you're going to append the name of the column. And then you're going to create a histogram of the data in train.call and the data in the column. And then you're going to print off the title, and then we're going to set the X ticks to rotate 45 degrees, and then you're going to show it. And then you're going to print the calls at the very end of it. So you're going to set up a for loop. So every column of data is going to be converted into a histogram. So this is compound. And so compound is, you've got the categorical values of hard, medium, intermediate, soft, and wet. And so you see medium is the most frequent compound to use. This is the race, and you've got tons of races. I think it's 26 races. So it's hard to see all of them, but you've got tons of races. This is the year. It's going to be 22, 23, 24, and 25, and 2 races for each year. You've got your pit stop is going to be 0 for no and 1 for yes. You've got your lap number, and it goes from 0 to 80 laps. You've got your stint, which is a number from 1 to 8. You've got your tire life, which is a number from 0 to 80. You've got your position, which is a number from, gives you values from 2.5 to 20. You've got your lap time, which is a number from 0 to 2,500. And you've got your lap time delta, which is a number with the center number is 0. You've got cumulative degradation, which is a number from 0 to 500. You've got race progress, which is a number from 0 to 1. You've got position change, which is a number from -15 to +15. You got pit next lap, and that's your target. So it's going to be 0 for no and 1 for yes. So you can see right here we have a class imbalance because you have a lot more zeros than you do 1. So this represents a class imbalance. So if in your practice you decide to use one of the sklearn models, be sure and make sure that model is set for balanced, because if you don't set it for balanced, it might not be correct. So, and now what we're doing is we're printing off all of the features. So you've got a printout of all the features that we just made histograms on. Now what you want to do is you want to pre-process your data. And so you're going to make your target is train.pop brackets pit next lap. So basically when you use the pop function, what that does is that just takes that column, that feature out. Just takes the feature out. So you've got train.pop pit next lap. And then so we're going to look at the first 5 rows of the target and the last 5 rows of the target. So you can look at that, see whether it is a 1 or a 0. So now we're going to initialize an empty list to store categorical columns in the train data frame. So we're going to create the empty list called cat_calls. And then we're going to iterate through the data frame columns. So for call in train.columns, if train call.dtype equals object, we're going to add to the column to the list. Print call, train call dot unique, and then print call, train call dot inunique. So unique is going to print off the unique variables, and each unique variable, each unique value, and inunique is going to print off the number of unique values. And then so you're going to append that column name to cat calls. So you can see that I've already deleted or dropped the driver. So the driver is not there. But if I hadn't dropped the driver, then you would see that there were over 800 and something unique values for the driver. But the problem that you have is that the unique values in the train set is different from the unique values in the test set. And because of that, you would have, when we run up the Catboost classifier, because of that, the Catboost classifier will give you a different shape for the train set than it gives you for the test set, and that will mean that the Catboost classifier won't work. And because of that, I just decided to delete the driver column and hope for the best. So in the compound column, you've got 5 unique values, and in the race column, you've got 26 unique values. So now we're going to do the same thing in the test column. And in the test column, you have 5 unique values, and in the race column, you have 26 unique values. So you want, because this is a Catboost classifier, you want to have the unique values to be the same in the test that they are in the train files. And if the unique values are not the same, then the model's not going to work when you run it. So now we're going to find columns of D-type, integer, or float. So you've got your numCols, which is a blank list, and we're going to iterate through the data frame columns. So for call in train.columns, if train_call.dtype equals int, or train.call.dtype equals float, we're going to add the column to the list. numCols.append call. So you're going to add the column to the list. And then we print the numCols, and this is how many columns of data that you have that are a D-type, integer, or float, which is numeric. So now we're going to one-hot encode categorical columns of the data frame. For call in catcalls, temp equals pd.getDummies brackets trainCall.asTypeInt. So basically, every column that is of D-type object that is a categorical column, you're going to get dummies on all of the categories. And train equals pd.concat brackets train, temp, axis equals 1. So, and then train.drop catcalls, axis equals 1, in place equals true. And then you've got your shape. So you've got your shape as your number of rows and your number of columns. And the number of columns need to be the same for train as they are for test, because if they're not the same for train as they are for test, then the model won't work when you try to run it. And the thing is that whenever I started making this problem, I initially noticed that the number of columns for train was not the same as the number of columns for test, and that's why I had to drop the driver number, because that didn't match up. So now what we're going to do is we're going to do the same process for the test file, and you can see the test file has the same number of columns that you have for the train file, so that's a good sign. Now what we're going to do is we're going to define the dependent and independent variables. So Y is your target, X is your train data frame, and X test is your test data frame. And then what we're going to do is we're going to split the data set into training and validation sets. I said training and testing sets, but it's really training and validation sets. So X train, X val, Y train, Y val equals train test split, brackets X, comma, Y, comma, random state equals 42, but you can use any number you want, comma, test size equals 0.15, and that can be up to 30%, but I put 0.15, and then you check the shape of your training set and your validation set, and as long as the features are the same for the train set and the test set and the validation set, I think you're okay. Well, you are okay. And now we're going to define the model. So model equals Catboost Classifier, comma, loss function equals cross entropy, iterations equals 5,000, learning rate equals 0.1, depth equals 6, verbose equals 1,000. So that means every 1,000 iterations, it will print off what's going on. And then we say model fit X train, Y train. So now you fit the model. So we let the model run through 5,000 iterations, and you can see what your outcome is. So now we're going to make a prediction, and this is going to be YPred proba. We're going to make a prediction on the validation set. So YPred proba equals model.predict proba brackets X val, square brackets, colon, comma, 1. So basically, the value that you're going to be looking for, you're going to be getting an array of two values, but the value that you're looking for is the value on the first column. But the thing is with Python, in Python, the first number starts with 0, so the first column is going to be the second column, really. And then so we predict proba, and you can see we've got our percentages, which don't look very good, but that's what it came up with. Now we compute our accuracy. ROC-AUC equals ROC-AUC score, brackets Y val, comma, Y pred proba. So your validation set and your probability, and you get 95% accuracy on that when you run it and you print it. So now we're going to make predictions on the test set. So again, instead of testing on the validation set, you're going to test on the test set. And you get an array of predictions, which is pred proba. And these predictions look a little bit better to me. And so now what we're going to do is we're going to create a histogram of the predictions, which is a little bit similar to the previous histogram, the histogram of the target, but the code is similar. But when we run the predictions up, you can see that it's a probability. It's a value from 0 to 100%. And most of the values are close to 0. And the reason why is because the target had a class imbalance of mostly zeros and just a few ones. So after we have made our histogram of our probabilities, we're going to prepare our submission. So what you're going to do is you're going to take pred proba and you're going to put it into the submission column that says pit next lap. You're going to convert the submission data frame to a CSV file, and then you're going to read the submission data frame that you've just converted to a CSV file, and this is what you've come up with. This is the data frame that you've come up with, and this is what you are going to submit to Kaggle. And basically what you have to do is you have to save it. And then when you save it, you go and you run it. So when you save your work, what you're going to do is you're going to click here on output, and then when you click here on output, they're going to have a button to submit, and you submit your work after you've saved it. And when I submitted my work, I had 94.713%, and the highest value was 95%, and I thought, well, that's close enough. And I thought, if I had a lot of time, then I could try another model and see which model works best. But I don't have a lot of time, so I thought, well, this is a good score. It's just slightly less than the top score, so I'm happy with that. I'm going to do that. And so that is the end of this code review. So you've learned how to use Catboost Classifier to predict on the probability that a car is going to hit the next pit stop, going to pit next lap. So that concludes this video. If you like my video, please like and subscribe. And thank you so much for watching my video. I'm going to be making Kaggle competition every month. Every month I'm going to do a Kaggle competition and make a video on that. And I do videos on other things as well. So I do hope that you subscribe to my channel and see which other videos I have made. So thank you for watching.